Hello, everyone. My name is Natalia Marmol. I'm the co-founder of Enevia Health, a Spanish company dedicated to distribute lab tests using the diagnosis and treatment of neurodevelopmental disease. I am very proud to announce that our new website is finally finished. It's been 6 months of hard work, but finally it's online. I invite you all to check it out at www.eneviahealth.com. You will find more than 100 tests from more than 20 labs with many discounts in supplements, therapies, doctor visits, and more, with substantial discounts for autism families. At this moment, we are working in Europe and in Latin America, but some of our discounts can be used worldwide. In our new website, we have incorporated a new membership to include people outside the autism community to allow them to take care of their health, enjoying the discounts that Enevia has to offer. So please visit our new website. One thing that I need to say, and I'm a little bit sorry about it, is that we just have it in Spanish right now. So we are working very hard to get it translated in English. So please come back to us in probably about a couple of weeks, and we're hoping to have it in English. So now back to the interview. Today, we are going to be talking about a compound that I'm sure many of you have heard, either by the name of OSR, EMERAMIDE, or MVMI. This compound is a heavy metal chelator with many amazing properties that has the autism community very interested on. To talk about it, we have invited Dr. Hailey Boyd, the person that invented this compound. Welcome, doctor.
Thank you. Happy to be here.
Well, very glad to have you here. So now to introduce you to our audience, I have to say that when I was preparing this interview, I started researching your curriculum. But I realized that it was very long, full of achievements. So I think the best way to introduce you is to let yourself introduce to our audience. So please, if you don't mind.
You know, my name is Boyd Haley. I'm 80 years old. So, and what I have done, I was chairman. I was NIH funded to study biochemistry, biochemical approaches, and make technology. Like that for 25 years. So, I mean, my research career was very good. I'm retired now, totally retired for several years. And in the process of what I was developing and the compounds I made, they were very good for looking at medical tissue and telling what changed during a disease state. And with this, we looked some time ago, about the 1985 or 87, we looked at Alzheimer's disease brain to see what neurological changes were there. And we found major changes that we could detect with our compound. And then we decided, well, let's find out what causes that change. And we looked at toxins, because Alzheimer's disease and a lot of neurological diseases are not genetically inherited. You inherit the tendency to respond intently to certain toxins. And Alzheimer's disease was that. And so we published papers showing that it was mercury that could generate all the aberrant biochemistry that we observed in an Alzheimer's disease brain by adding it to normal brain tissues. And we have followed that up by taking rats and exposing them to mercury vapor, where mercury would build up in their brain. And as the mercury built up in their brain, we showed that their Alzheimer's-like aberrancies increased dramatically. So we published that, and that was not very popular with a lot of people in our government, because amalgam fillings are FDA approved, so is the mercury in vaccines. And I ended up in a fight that I knew nothing about, basically because there was a lot of consternation and a lot of aggravation about the fact that our government does not want mercury to be recognized as a major cause of a lot of illnesses, and neither does our American Dental Association. So
sorry,
that's how I got into this.
I was going to say, before you get into more detail, I just wanted to go a little step back and for you to explain, to start off, what is OSR, or you know, the different names that I mentioned before and YG and the way that you call it now, but mostly to explain from the beginning what is this compound and then how you got to develop it.
Okay, the thing about when that I recognize as a chemist, biochemist, is that there was no way to, we had still in the EMA or the FDA in the United States or Europe, we have no treatments for mercury toxicity, or the toxicity of most heavy metals. And so you looked at the compounds that were being used as chelators at that time, DMSA, DMPS, they're not really chelators. I mean, if you look at them, they have sulfur groups on two adjacent carbons. In other words, their sulfur groups are held out like my two fists, right, like this. And mercury cannot fit in between those two. So they cannot be chelators. And they do bind mercury, but they bind mercury in sandwich complexes where you have two DMSAs bound per mercury atom. And that is how they bind. So, but they're not true chelators, and they're charged. They're hydrophilic. In other words, they cannot go through a biomembrane. And so when you take OSR and it gets in your body, into your blood, it never enters the cells of your body because it's hydrophilic. So what I decided to do was to make a compound that one, would have the sulfurs on long arms like my arms, and that if the metal, so the metal like mercury could fit in between it because it can come in like this, and it can change its conformation and bind several different metals that are toxic. All they have to do is have attraction for sulfurs. And what we made was a compound like that. And we made this compound uncharged, so it could go through biomembranes. It can cross the blood-brain barrier. It can get inside cells. It can get inside your mitochondria. And that's where the toxic metals go. Mercury vapor or mercury cation crosses the blood-brain barrier, gets inside your brain tissues, gets converted to Hg2+ and goes wherever it wants. And so we have to have a compound that can get to it. DMPS and DMSA cannot get into mitochondria. They cannot get into the central nervous system, and they're excreted very rapidly from the blood. So they were not expected to work. Plus, they bind all of the essential metals too. And this was something I was really surprised that NBMI did not bind and deplete essential metals. But the fact that it stays it's hydrophobic, so it stays in the lipid bilayers primarily, means it doesn't get near to the heme and the red blood cells, so it doesn't get near that iron, and it can't bind it. It just doesn't bind it. And to make a long story short, that was my major concern to start with, and I did increased studies to see what effect NBMI would have on iron and copper and zinc levels. It has no effect. I mean, you have to go to incredibly high dosages for it to have an effect on essential metals.
So just to make it clear for everyone, what is it, OSR? What compound is it? It's formed by?
It's you want me to show you a structure of it?
No need. I think it just to give one step back. So for people that just for the first time is listening and it's hearing, so I want them to understand that we're talking about a chelator and we're talking about a compound that it's formed by two molecules, I would say. So can you explain a little bit, just in an easy way to understand, but then we can go from there to see what are the properties of this compound.
Okay, the compound is made from two naturally occurring compounds because I wanted it to be accepted as a dietary antioxidant. And what I did is I took two antioxidants that exist in nature. One of them is a dicarboxybenzoate, which is found in cranberries and berries that are tart, and it's been studied, and it is used if folks at home want carboxybenzoates are totally non-toxic. They're excreted very rapidly, and you'll see if you pick up your beer or your Coke or whatever you're drinking, you'll see it's preserved with benzoates because they scavenge hydroxy radicals and they keep food from souring. And to that, I wanted another molecule that had sulfur in it because sulfur is the major atom that binds toxic metals. And so we use cysteamine. Cysteamine is a breakdown product of cysteine and it's found in your body. It's on the terminal end of coenzyme A, and it has a sulfur on it. So I attached two sulfurs, like this is a cysteamine, and this is a cysteamine, and this body here is the benzoate. And so we have two non-toxic biomolecules connected together that are designed to have the ability to bind mercury in between them. That was my original, the original idea of the group that I worked with at UK that did it. It was a graduate student that did the work, actually. His name is Matlock. And so that is just, this compound is made out of two non-toxic compounds. And then when you put the two together, there's no charge on the molecule. So the molecule can go through your lipid bilayers, and it penetrates the body. It gets in, and we've done this now by testing. When you take it, it has a 22-hour half-life in your blood.
22. Okay.
Yeah. I mean, this is on rats now and on humans. And when you take it, it gets into your plasma. It circulates through the body, and we've done, by using a radioactive compound, we've shown that it penetrates every tissue of the body. I mean, it crosses the blood-brain barrier, gets into the central nervous system, gets into the most every organ of the body, and it does that from the plasma. But once the plasma levels drop down, because they've delivered it like they deliver the fat, like alpha lipoic acid, which you eat and you need, this same system delivers that alpha lipoic acid to all the cells of your body. And so our compound just kind of latches onto that hydrophobicity and goes into, and has been proven, goes into all the tissues of the body. And after it's in there for a period of time, and then it gets excreted. Because your body has a process called the P450 system that takes compounds that are building up there and puts a marker on them so they get excreted. And your kidney also gets involved in this excretion process. Now, in the case of NBMI, one of the added positive things, other than the fact that it binds mercury and never lets go of it, we call it thermodynamic irreversible. It binds mercury, lead, cadmium, iron, and these thermodynamically irreversible processes. And once they're bound, it never lets go. I mean, not in the lifetime that would be in your body. And so it eliminates the toxicity of several metals, including unbound iron, which is the cause of oxidative stress.
Okay, let's talk about this in a little bit more detail. Let me just rewind something for everyone to have it very clear in their mind. So we're talking about a chelator that, let's say, binds to the mercury and doesn't let go. So that is one of the major things that everybody has the problem when they're doing chelation, that we're talking about redistribution. So all the chelators that they are out there, they bind into the metals and then let go and bind continuously. So we're talking that doesn't do that. It gets.
It's not. And the reason people think our compound does that is because that's what DMPS and DMSA do, because they're not true chelators.
Okay, that's very important. And I think that it's definitely one of the best qualities that OSR and BMI has. And so talking now, you mentioned the oxidative stress. Let's go into that, which is also another amazing property that has.
What the audience needs to know is if you have oxidative stress, that means you're producing hydroxy free radicals. And the electron donation to cause the formation of a free radical in the body is through the Fenton reaction. And what does that would be iron or copper. They're unbound. They're not, and there's no free iron or free copper in a healthy body. I mean, very, very low levels, because your body has made all of these protective mechanisms like ferritin, etc., to bind any free iron so that it's not out there making hydroxy free radicals. And the nice thing about NBMI, once it binds iron almost as tightly as it binds mercury. It binds mercury a lot tighter, but they're both incredibly tight. When it binds that iron, it covers up the electron shell of that iron, so it cannot be involved in making hydroxy free radicals anymore. So it immediately prevents the iron in your body that's not bound, that's been displaced by mercury. Because see, mercury is Hg2+. And once it gets in your body, especially in the mitochondria, we know it displaces iron from the iron-sulfur complexes of the electron transport system. And so you now have unbound iron in mitochondria, which also is very high in oxygen that you breathe, because that's where you make ATP. And that iron gets involved in the process to donate an electron to that oxygen, making it superoxide anion, which leads into hydroxy free radicals and the toxicity. So binding that eliminates its ability to do it, and it totally stops the oxidative stress.
Dr. Let me ask you something. In your experience, back at the time, well, I'm just saying something that I wanted to talk later, but back at the time when OSR was sold in the US as a dietary supplement, did you have any report from any medical doctor that was treating patients about the improvement of mitochondrial dysfunctions in ASD children?
We sold it for 2 years. And I only sold it through medical doctors and dentists because I wanted somebody that was watching, and I would, tell people, watch these autistic children, because I was pretty certain it was safe. I mean, all the animal studies, and I had taken it myself. There was nothing about it that would make me think it was dangerous. We sold it for 2 years. We didn't have a single significant drug-related adverse effect reported to our website. Mm-hmm. And neither did the FDA. No medical doctors, and then basically that was who had it first, medical doctors and dentists who know about the FDA and the reporting of adverse effects of drugs. There was not one report in the 2 years. But what happened was that mothers like yourself with autistic children started blogging that this compound was good for treatment of autistic children, and talking about how it reduced dramatically the intestinal problems these children exhibited, and they started looking at them, and they started saying words, and they started telling everybody you should do it. And this got back to, I think, the pediatricians in the United States, and they came down to the conclusion that these people were treating autistic children with a dietary agent. And the concept in the United States, if something is used to treat a medical condition, it has to be a drug.
But before that, it got, you guys were stopped. Let's say the doctors that that use OSR, that actually treated patients that had mitochondrial dysfunction in this case, did they report back to you that they were seeing improvements in the?
Oh yeah.
Do you remember any particular case with mitochondrial dysfunction?
What I have, I have 2 electronic files where I have copied all of the emails I got, because as I got emails back, primarily, that's what I could, I would save those emails, and I tried to show them to the FDA, but they weren't interested in it. These were emails from medical doctors and parents telling me sometimes the phenomenal, almost unbelievable repair or improvement in their children, and people also with tremors, etc., that we were getting with NBMI. So I was making something to put in a book, and to convince people that came in that it would work, because I thought the FDA would be interested in what people were seeing. And so I have 2 electronic files of copies of these emails. I don't know how many are in there. I haven't counted them, but there's a hell of a lot more than 20 or 50. And so I can provide those. I can look it up and say, here's what this person found out. And some of them, but there wasn't one of them that said that this compound made them sick. They were all grateful, almost all of them grateful things where people were telling me how well the compound worked.
I just want to get a little bit into the specifics, because I know that it's what people that it's listening wants to hear what you remember from back at the time that people used to report. I know that it's been a while, and I know that probably there were reports of other families, but it's important to see. So I know that I heard other people saying that, again, as you were saying, that it was helping with gastrointestinal issues. Would you have any specifics? So how was it helping?
I can tell you, whenever I would give a talk at an autism conference, there would be mothers, especially at the end after I put out all OSR, there would be mothers come up and give me a hug and tell me how grateful they were that their child was no longer having bowel movements in their pants after they were, say, 4 or 5 years old. It stopped. the children became more capable of controlling their bowels and being potty trained. That was the major thing I remember. But they would also tell me that because of the loss of the pain, that these children were now speaking and making eye contact. Now, you got to understand that would probably be in the last half of the 2 years I sold it before the FDA shut me down. But the reason it was all over the mothers on blog sites were giving the compound very high marks, and this was irritating certain people in the medical community. And the real reason was because the compound, as well as being an antioxidant, which I think, we didn't talk about that enough.
Yeah, we'll go back now to where we're supposed to more the theory about it.
Because when you take this compound, if you take this compound and test it against hydroxyl-free radicals, it scavenges them immediately. It stops the damage being done the minute it gets into your bloodstream, it peaks in 2 hours after you take an oral dose, and it starts scavenging hydroxy-free radicals and preventing the damage to the membranes, the biomembranes that line the arteries and line the intestines. And when it does that, it ends the toxicity. And what we've seen from rats that we gave lethal doses to and saved. We have given this, and that publication I sent it to you shows that you can give rats a lethal dose, 2 lethal doses, and if you treat them with OSR immediately 20 minutes later, they don't even get sick because it goes in and binds that mercury. The mercury's still in the body, but the rats don't die. They don't get sick. They don't lose weight. And that's because it binds it into this complex that's totally inert and eliminates the toxicity. It doesn't get the mercury out of the body that fast. That takes probably 72 hours for the mercury to be excreted.
Do you know, so talking about the gut, and I was just thinking, so for example, in those persons that they have a lot of biofilm recovering, let's say, the intestinal tract, and that biofilm is also encapsulating somehow mercury, would the OSR be able to cross this biofilm in order to get into this mercury that might be trapped in this biofilm?
I can't say that I've done any experiments directly on that, but OSR is very hydrophobic. I mean, it'll go where mercury vapor goes into those places because it's uncharged. And it doesn't like being in water. Mercury does not like being in water, vapor. It will go, in other words, if you take 2 beakers, one with water and one with mercury, and you put mercury into under a big glass ceiling, all the mercury will end up in the oil. It won't end up in the water. The vapor goes up and it goes into the oil because that's where it likes to go. That's the reason it's such a neurotoxin. The fatty tissue of your brain really absorbs it a lot, and that's where it prefers to go. And but NBMI would do the same thing. NBMI is very hydrophobic. I mean, it likes the oil, it likes the lipid bilayer, but it can get, when it goes in there, once it reacts with hydroxy-free radicals, it forms a sulfite, which is charged, and it goes out through the kidney.
Did you ever do any, oh, sorry, I interrupted you.
Yeah. No, that's all right.
I was just going to say, did you ever do any biopsy, brain biopsy of any animal in which you had previously, let's say, get mercury toxic, then treated, and then examine that brain to see if there was any any residues of the mercury, or it was totally gone?
Oh yeah, we have. I present that in my talks all the time. We took rats and gave them a non-lethal dose of mercury, and then you could sacrifice some of the rats, like we did 20 rats, and we could sacrifice them at different time points and say, how long does the mercury stay there? And how long does the mercury stay there if you treat them with NBMI? And what happens? Both NBMI and mercury go out bound as glutathione complexes from the brain. And so they both go out at about the same time, but both of them the mercury will leave. I mean, it'll be totally gone within 30 days.
In 30 days. And that's in rats. So
but with you got to understand, once mercury does not, to lose this toxicity, with NBMI bound does not have to leave the brain. It stops the toxicity immediately. And one thing that we have done, I did this myself. I made in my laboratory, I combined mercury and NBMI to make an NBMI mercury complex that precipitate out of the water. You have mercury that's water soluble, Hg2 plus, you add NBMI and methanol, and the mercury will all precipitate out into the a white precipitate at the bottom. So you can isolate it, you can do all the chemistry to show that that is indeed mercury NBMI complex. And I sent that off to Southern Research Institutes in the United States that does toxicity testing. And they took the compound and they gave 2 grams orally to a rat. That's enough to kill 100 rats. I don't know, maybe even more. I don't know how, but the 2 grams of mercury NBMI complex did not make the rats even sick. And we sacrificed those rats because the mercury did get in the brain, and we looked for oxidative stress markers. There was no sign of any toxicity by the mercury NBMI complex being ingested for a long time, for over a week, at very high concentrations. The NBMI just totally eliminates and makes the mercury totally inert and non-toxic. And the mercury did get into some tissues. It got into the tissues at levels that if it were straight mercury alone, it would have caused a toxic effect because we gave such massive amounts.
Okay, so going back to the properties of OSR, so we talk about the properties of being an amazing chelator. We talked about how it reduces oxidative stress, and I think you just mentioned a little bit about the glutathione, so how it did increase. So can we talk about its last property?
Yeah, the one biological property of glutathione is that it's supposed to scavenge hydroxy-free radicals that escape your electron transport system. That's what it does on me right now and you right now. It's our protection against oxidative stress. And it does this, and when you suffer from oxidative stress, your glutathione levels drop. And for example, when they had the COVID deal, the people that got sick and died of COVID were the old people. When you get old, your glutathione levels drop off dramatically. And so you can't protect yourself from viral infections because the glutathione is what really binds to viruses to prevent them from being toxic. But we did a study. We took 5 older people and 5 younger people. This is when it was OSR. And we paid 2 medical doctors. Both of them had an autistic child. And so their 2 children were in the thing. And we gave them OSR to give to their children over a 2-week period. And we looked at their blood glutathione levels as we did that. They started out, and there were also 5 older people that had much lower glutathione levels than the younger people. And when we gave all 10 of these people, and we measured 200 biochemical parameters, blood and urine tests to check what effect this compound might have, because I did not want to put it out on the market and have it used if it was going to affect something. The major thing that changed dramatically were the glutathione levels in these people. The reduced glutathione levels went up dramatically in both the older people and the autistic children. And the autistic children were getting better. The one little girl wouldn't even go near the swimming pool that was autistic. And by the time she finished her treatment with OSR, she was swimming, not the length of the pool, but across the pool in the backyard of their, that's what they reported to me anyway. And it really helped. But the one thing that OSR does is it builds up the glutathione levels in the tissue, the red blood cells of people. And I would think all other tissues also. And it does the same thing in cells in culture. If you take cells in culture that you can add mercury to and kill, and you follow the glutathione, the first thing mercury does is it causes the glutathione levels to go from this high down to nothing. And if you give them OSR first, if you treat those cells with OSR first, it has no effect. The mercury has no effect on reducing the glutathione levels. Even control cells that aren't dying, if you give NBMI, their glutathione levels will go up higher than controls. So NBMI is very good at increasing the glutathione levels inside tissues.
Okay, so we basically saying that there's a lot of people, a lot of autistic children that have very low glutathione levels. So we're talking here that with this compound, they could actually just, not even talking about the metals or anything else, we could just bring up these reserves of glutathione, which that itself, it would be a great help. Not to mention what we're saying about reducing oxidative stress. There is one thing that I'm curious if you know more in detail. So we're saying that when we take the OSR, the first thing that it would do is it would go to bind into the free iron, no, to reduce that oxidative stress. Then what's left, I'm assuming the next step will go to bind into metals. But I'm assuming that as long as the oxidative stress is high and you don't have enough of this compound in your body, everything will go to bound into the oxidative stress, right? So there's an affinity for going first to this unbound iron before to go to the heavy metals. Is that right?
Yes. But that's what it would run into first. But you can understand it goes through the body. When you take radioactive NBMI and you put it in a rat and you watch it gets into the intestines first, and then it transports into the plasma of the blood, and then it goes from the plasma of the blood into all the tissues of the body. You can watch the radioactivity build up in the kidney and the liver, etc., with time, and then. But one thing you have to understand, NBMI also has a property, a chemically reactive property, in that it scavenges hydroxy radicals.
Mm-hmm.
I mean, when you take it, it does two things that are protective against heavy metal toxicity. Number one is it binds a metal and keeps the metal from making any more hydroxy free radicals. And every hydroxy free radical it runs into, it scavenges and reacts just like glutathione does. And in doing the scavenging of the hydroxy radicals that are there or being produced, it causes your reduced glutathione levels to increase, which is very good for you. I mean, that's healthy. That's what most people do. When I was a graduate student, I went to a talk by some eminent scientists at the Federation of Experimental Biochemists. And there were three very intelligent gentlemen that were talking. And the one guy, and it stuck with me forever, and I dug it out, he said, the holy grail of medicine is to make a drug that increases intracellular glutathione. And that's what I've done. And I didn't do it because he said it, because that was a lot of years I didn't even know what glutathione was, really.
So you mostly basically doing an anti-aging supplement at this point.
It should be a supplement. I mean, in my opinion, is that this compound is non-toxic. It's made out of 2 food products that are non-toxic. And the FDA does that because they like to control anything that's used to treat a disease. And that's what they say. You go ask them. They have a mantra. If it cures an illness, it's a drug, not a food. I mean, they forget all about plague and other illnesses that are caused by lack of supplement, lack of the proper food. So, I mean, you know, the thing is, the FDA has a very hard job to do, and I appreciate that. But they're also not proactive. They do not, for example, they came after me. They found out about me because people were reporting on blog sites that the compound was very effective at treating autism. They can say some other things, but there was nothing else that it was being used for at that time. And they told me that since it's being used to treat a disease, which is autism, and there were some reports of it treating rheumatoid arthritis. It does a great job on people with rheumatoid arthritis, by the way, which is oxidative stress and metals. But they shut me down because the compound worked. And the mothers made the claims. I didn't make the claims. I was smart enough not to do that. There was never any sign on our website selling OSR as a dietary antioxidant where we said it chelated metals. We couldn't say that because I knew that would make it a medical product, and they would make me take it through they would make me stop selling it because of making a medical claim.
Yeah, it's a pity that it happened, because if it was helping a lot of people, and I'm sure it was, because we've heard the reports of many families saying so, it's definitely not helping anyone, that it stops you. So tell us, at what point are you right now with trying to get FDA approval?
We have done, if you go to the FDA, if you want to get a drug approved, they tell you everything you have to do. We have to show it's not toxic in 2 species of animals. We've done 6. And then you have to show, you have to have a mechanism of action. We have shown that its mechanism of action is it binds hydroxy-free radicals, eliminating them. It binds toxic metals and eliminating their toxicity. We've shown that. We've shown that in 10 years of research. We have spent millions of dollars doing these studies, and not me doing them. They're being done by clinical research organizations that are, like every pharmaceutical company would use. And we have fulfilled everything, and we have submitted all this to the FDA. And the last meeting we had with them, they rarely say as little. They say as little as possible that you can use, but they said that they told us the compound is absolutely safe for use in humans and animals. We've shown that it's not toxic. It doesn't cause anything. It prevents death, and so, with massive amounts. So if it does that, it's probably eliminating all the toxic effects that you can get with a metal. But they asked us to do for efficacy. They said, you have shown that it's efficacious in preventing mercury toxicity in animals, but you haven't proven it in humans. Well, we haven't, because I'm not a medical doctor, and not only that, you have to get it approved through the FDA before we can give it to a human. So right now, with the last meeting we had with them, they said what we need to do is we need to find a group of mercury toxic human beings to give this to, and they couldn't identify such a group in the United States because they say there's no mercury toxicity in humans in the United States. I don't believe that. I mean, I think a lot of people with a lot of dental amalgams have mercury-related problems, but they're just not recognized by the medical community. But so what we've done is we've gone to South America, to a place where there are a lot of gold mining, and we did a study on Ecuadorian gold miners, but they're too poor to take the drug and quit work. They have to keep going back to work, and so they kept exposing themselves. But it worked. I mean, 300 those that got 300 milligrams a day in our Ecuadorian study showed a tremendous drop of mercury in their urine, indicating that it was being tied up and rendered non-toxic. They also saw a significant drop in pain. But the bottom line was that the controls were all up and down because of how much they breathed mercury that day. So it was not good statistical data. So we're now doing this on people that are not gold miners, but are mercury toxic because of the food they eat and the air they breathe. And that is just started. We're doing that right now. And we're hoping that the FDA will accept it from South America.
Okay, so one thing that I would like to say from here is that obviously all this research and everything that needs to be done in order to get FDA approval is not cheap. So the same way that for other types of treatments and for other types of medicines and supplements, the community has made the effort to helping those researchers. What I would ask from here is that whoever has the possibility to help, in any way whatsoever, and to get some funding, I'm sure that will help to keep on going and to keep on funding all this research that needs to be presented to the FDA in order to get the approvals. So from here, I would just say that your company is called EMERAMIDE. I always say cross with EMERAMIDE. What is the name exactly?
EMERAMIDE.
Okay, there is a website which
is medical for medical.
Okay, so we'll put the details on the comment. So if there is anyone listening that thinks that can help, so please get in contact with them. And so now going back to autism,
we don't take handouts. We don't ask people to donate free. We started a company and we have stock in that company, and we've been selling it because the compound is going to make money. I mean, I can't have it not be a drug. I mean, because the FDA tell me I can't I cannot give it out as a dietary supplement. I don't think they'll ever allow me to do that. But the compound, since it binds unbound iron, makes it an incredibly expensive, potent drug. I mean, if it gets approved for binding unbound iron or binding other, stopping other diseases like oxidative stress disease, based diseases, which are most of them, the compound is going to make a lot of money. And so we sell stock, and we use all that money. I don't, look, I'm 80 years old. I don't want to own another boat or a sports car or a house in Paris. I am just dedicated to getting this compound out and accepted and used in the world. And I want to keep it available for people who don't have money and who aren't rich. I mean, this should not be a rich man's drug. And it won't be if I have anything to say about it. But the thing is, it is still going to make a lot of money, even sold at a very cheap price. And so we sell stock in our company, and we use that money from the stock to fund the mercury toxicity studies we have to do to get it going. And so that's where we are now. So if people are interested, if you invest in the company and the company is wide open, I don't have any secrets at all. I don't live that way at all. I don't have any.
Okay, so that's great to know. And as we said, so if anyone is interested, please get in contact with them. And now I like to ask you some of the questions that the parents have been sending to us to ask you. I know there are questions that you cannot answer because you're not a medical doctor, but there is the biggest question that everyone always wonder is about dosage. So if when it was available, what type of dosing were parents giving to their children, or were the doctors giving to their patients? So are we talking about long-term treatments? Are we talking about 2-week treatment and so high dose and then getting it out? How do you remember what were they doing?
Yeah, the younger the children were, the more rapid and the more complete the reversal of the autism. I mean, this is from people telling me.
Yes.
I didn't treat one child. I want everybody to know that I didn't treat one child. I talked to the parents and the doctors that did. And what we saw, the younger they were, the better it worked and the faster it worked. And the
young as babies or young as 2 years old?
Yes, babies. Some of the medical doctors who knew a lot about it that had autistic babies would come to me, and they were looking at the porphyrin profile. Okay. And the porphyrin profile is porphyrins are made in the mitochondria, and they're used to they cross into the mitochondria and are converted into heme. And if you're mercury toxic, you have a very unusual porphyrin profile that people can identify by just analyzing the baby's urine. And what they reported to me is that when they gave their babies NBMI, the porphyrin profiles went back to normal, because mercury inhibits one specific site in that 6 reaction pathway, causing pre-pro porphyrin to elevate in the body, in the urine, as it gets excreted. So they can tell whether you're mercury toxic by looking at your porphyrin profile. To do that, to prevent that mercury toxicity or to reverse that mercury toxicity, NBMI not only had to get into the brain cells, it had to get into the mitochondria, because that enzyme is located on the outer aspect of the inner mitochondrial membrane. So we know it goes wherever mercury goes.
Perfect. That's great to know. Let's talk about, there is one thing that you always mention in your interviews that people should be aware when taking OSR. And we know that autistic children have certain problems with sulfur, not sulfur, sulfite. How do you say it in English? Sulfates. Yeah. Sulfates, sorry. Can you elaborate a little bit more this?
Yes, I can, but it's not a problem with sulfate. It's a problem with sulfur metabolism. And there are a lot of people that have that. Women that people that can't drink red wine because of sulfite. Well, it's the sulfite that's toxic. But when the body metabolizes SH, one of the steps in there is sulfite. I mean, because it's trying to convert to get rid of excess sulfur in your body. The body converts it first to sulfite, SO3 minus, And then that SO3 minus, which is very toxic, is converted to SO4, which is sulfate, which is not toxic because it's rapidly excreted by the kidney. Now, people that, if you look at a publication by Rosemary Waring, an English lady, a medical doctor, she studied autistic children, and what she noted and said in it is that autistic children have 50 times the sulfite level, which is toxic, as do neurotypical children. And she also, knowing something about the enzymology, said if she gave these children molybdenum, a lot of them got better. Now, why is that? Because I'm a biochemist. I recognize right away what it was. The enzyme that takes sulfite in the body and converts it to sulfate is called sulfite oxidase, because you're oxidizing sulfite to make sulfate. You're taking a non-toxic compound, a toxic compound to a non-toxic compound. That enzyme requires as a cofactor molybdotera. In other words, it requires molybdenum. And that's the reason people take molybdenum supplementation if they have a problem digesting sulfur drugs, etc. And so when we treated, when we sold OSR, we had 2 or 3 babies or parents come back and say, my child can't take it. They develop a rash and they get sick and they don't feel good. And we would say, well, stop the OSR. And when they did, the rash went away. And then put your child on a molybdenum supplement, which is you can buy in Walmart. When they did that and start over and then start out very low and go slowly build up to the 100 milligrams a day. That's what we were treating at that time. And so every one of them could do that. So if you're a child that's born with a genetically impaired sulfite oxidase enzyme, you're going to die by the time you're 3 years old. That's according to the literature. If it's genetic, you can't reverse it with molybdenum. Yeah. But most of it in the world today is due to lack of molybdenum in the diet. And I will tell you, I have done this probably 30 times in my life, talking to people who hate wine. They won't drink wine because it makes them sick, gives them a headache, makes them have rashes. They just don't drink it. And I say, would you do me a favor? Would you take a molybdenum supplement for 2 weeks and then try the wine again and see if it makes you sick? And almost invariably, everyone comes back and says, I couldn't drink wine before because it made me flush, made me ill. And now I don't have any trouble with it at all.
Okay, so do you think that a couple of weeks before taking OSR would be good to start molybdenum and then start?
I think if you have an autistic child, they ought to be on a molybdenum supplementation forever.
Okay, and one thing that we have said that I think is very important when taking other supplements together with the OSR. So is it important to separate the uptake of the other supplements? For example, if you're taking minerals, it's important to take it how many hours away from OSR?
Well, we know that if you take OSR radioactive, most of it is in your blood and in your cells by the end of 3 or 4 hours. So I would say take molybdenum or any supplement that's metal at least 4 hours after you've ingested the drug. The more you separate it, the better it would be. But definitely it gets into the body, peaks in the plasma 2 hours after you swallow the pill. And it gets in the plasma, but then it gets out of the plasma into the tissues over the next hour or two. And then it starts getting excreted. Okay,
so what about taking OSR at night or during the day? Have you ever seen difference?
No, we haven't seen any difference. I think taking it in the evening would be the best time.
You think so?
It doesn't seem. The major problem with autistic children is that they're pretty particular about what they will eat. I have get my advice usually when I talk to parents of autistic children, mix it with something like peanut butter or apple butter or applesauce or something that they'll eat, because it doesn't dissolve in water. It'll just float on any drink you get. But if you mix it with something that's kind of has a consistency of apple butter, you can give it to them and they'll eat it. They won't even taste it.
What about coconut? That's one of the things I've heard. So being like a fat and being able to, I mean, it's not
I
the
think that would be
tastiest.
fine. I can't think of any reason why coconut oil wouldn't be good for it, to mix with it, to dissolve it and get it in the body. Now, we talked about those autistic children that we treated and watched their glutathione levels go up. The one little girl was super sensitive. If she saw her mom touch her food, she only ate very few things.
Mm-hmm.
So her mother treated her with NBMI by mixing it with olive oil and rubbing it on her thighs. And then it'll go right straight through the skin. When I first started using the compound and inventing it, and I wanted to see if it was toxic, my initial treatment to see if it was toxic to tissues was to put it on my hand with DMSO and rub it in, and it would just totally disappear. And I would do that for several days, and then I would look my hands together like this and look at them and see which one. And the one that was getting the OSR looked better than the one that wasn't. And so, I mean, really, that's
that could be a new treatment, a new opportunity, skincare.
Right. Well, I think it would be good for skin care. I mean, matter of fact, the people that take it have nice skin. I'm not trying to brag about my skin, but I'm 80 years old, 82 this year. And you can see that I don't have many wrinkles. And I've been taking it since 2006. So
is that the secret from OSR that you don't want to share to the world? So we need to all start putting it in our faces.
Well, I have no secrets that I don't want to share. There are things I can't say because the FDA will wring my neck.
I know. Okay, so now I have lots of questions that I've been given by parents. So do you mind if I give you some of the questions, and the ones you can answer, you answer, and the ones that you think you are not allowed, and then we move on to the next one. So let's see. We were talking about the sulfur sensitivity. So then one of the questions I was saying before is about dosage. So tell us, let's say, like a little guidance. So you talk about before about 100 milligrams being a common used dosage. So let's say if you have a child, like 7, 8, 9 years old child, what were the doses that people were doing, and for how long? Do you remember?
Yes, I do. I can tell. I have. That's been a long time now. But when we started out, we said 100 milligrams a day because we wanted to be safe. We knew that worked, but it didn't mean it worked the best. But if you can't do work on humans, which I couldn't, I could not decide what would be the best amount. But if you give 100 milligrams a day, the thing I can tell you today, we have treated humans now with this on phase 1 projects under medical supervision. I didn't do it. And we've gone up to 650 milligrams a day on young people, and it's not toxic. We have not been able to give enough to make it toxic. I mean, and so what the parents should really know is that if it's OSR from my synthesis or NBMI from my synthesis, there's no toxicity associated with it. You can go to over 1,000 milligrams a day and it won't make you sick. It's not toxic. It's just going to go through your body, but you're going to waste it. And I would say most medical doctors, when I gave it out as OSR, I worked with one medical doctor who was very interested in it. And he started increasing the amounts he gave, not only children, but older people that had arthritis. And he said, you're way underdosing. He said, I got much better results when I gave 200 milligrams a day than we did. And you understand, we were being very careful back then.
200 milligrams to children?
Yes. And a lot of the parents will tell me that that's just not, especially if you have a 14-year-old. I mean, there's one child, this lady would be very happy to talk to anybody about it. She called me on the phone and it sounded like she was in a barroom fight. And I said, what is that noise? She said, oh, that's Adam. He's autistic and he's having a meltdown. And she says, and the doctors have the people at school told me I can't bring him back to where he goes to school because he was about 12 or 14 at that time. And he had broken a little girl's arm. He had thrown a chair through a window, and they told him he can't come back. He can't come back to our school. And she said, and she was crying and, touching my heart. And so I sent her OSR and I said, and with a scoop to give to him. And she said, he had one more meltdown after he started taking OSR. And then after that, it all went away. And his nickname was Adam Bomb. And anyway, he now calls me on a regular basis. He's not totally cured, but he from that day on, he never ever had a meltdown where he tried to hit his mother or break up anything. He turned into a big baby Huey. I mean that nicely. He was a very polite kid that got very much involved with computer games. And he calls me, and he sounds like Forrest Gump a bit when he talks. But he made it through high school. He's got jobs. He's going to be able to support himself. He's going to be able to live by himself when he has to. And he can change himself, take a bath, understand stuff like that. He's doing well. He is never going to get a college degree.
And what type of dosing and for how long in this case? Just to have an idea.
I think she went up to over 200 to 300 milligrams a day because he was a big kid.
But how long did she take the OSR?
She claims that he needs it all the time because he's kind of damaged. And it does help make people feel good. I mean, like, I don't need to take it either. But I can tell you, if I don't take it, after a period of time, my tremor will come back. But if I take it, once or twice a week, I don't have any trouble at all.
But
so
in case of that,
to answer your question, we don't know the answer to that. We don't know. It's going to be probably very personal with each individual person. But I can tell you, certain children that were less than 4 years of age that took OSR don't take it anymore at all.
Okay.
And they're normal, totally normal.
Is it important, for example, the people that might think about taking it for a long time, is it important to have rest, or it's okay to keep on going?
Oh, I don't think you have. I don't stop. I mean, I take it literally every day. It's in my medicine cabinet. When I leave, when I get up in the morning and shave, I put some in my hand, fill it in my mouth, and sublingually dissolve it. So, okay. I mean, I'm doing this because I want. I mean, there are people out there that don't want a cure for any disease. I mean, they want to treat. They want to bring you in and give you an IV and make a lot of money treating you or giving you something. This compound. I gave this to one lady. This is a true story. She lived in northern Canada, and she had a child that had seizures. He was autistic, and he had seizures. And she called me and talked to me. And so I sent her this stuff. She couldn't get to a medical doctor easily. And I said, just give it to him. I said, but what I want you to do is to plot the amount of seizure medals. She says, because you can see the seizures coming on. And she would give me medication and would stop it. I said, just plot how many medications you give him every day and see if the OSR helps. And she agreed. And so we did a little project together. And what happened before she finished the first 8-gram container of OSR that I gave her, his seizures totally were gone. I mean, she never had to use any seizure medication at all. Now, I don't know, that's one person, and that doesn't prove anything really.
But you mean she took the child took the OSR and then the seizures stopped after that?
Yeah.
Why do you think is that? How do you think the OSR worked in order to stop the seizures? It
stops oxidative stress. Everybody will agree. Autistic children suffer from oxidative stress. Yeah. And Rosemary Waring showed that most of them had excessive sulfite levels in their bodies compared to neurotypical children. So, the thing is, I think there are people who financially have an advantage if autism continues on. And they will say anything to shut something down. Heavy metal toxicity in the United States is rampant. I mean, the NHANES study, the National Health and Environmental Medicine Group, they did a study on the blood of 6,000 American women. They do that every year, and they look at children also. And what they have found, and then they also did a study on baby food. And they found that most baby food sold in the United States, 85% of it contained toxic metals at a high level that shouldn't be given to a baby. So if food is toxic, if we're breathing stuff from coal-fired power plants, if we're taking vaccines with ethyl mercury in it, if we're taking dental amalgams, it's an impossible situation to study. And so that's the reason I thought that EMERAMIDE would be a good compound. Because if you take that, say if you're mercury toxic, it'll bind up your mercury. It'll get rid. If you do it in rats, if you inject it in rats, you can see it binds up all the mercury, goes out in the feces or the urine, 95% of it within 24 hours. I mean, we paid people to do that. And so what happens to it when it goes out of your body? It goes down your toilet, into your septic system, into the sewer. And as long as that EMERAMIDE, those two sulfurs are on that mercury is never going to be released, and it's never going to be toxic. It's going to be like mercury in the environment. I mean, in the soil that we release by burning coal and doing other things. So this compound could help clean up the environment as well. If you take it long enough and you have, say, a huge number of people taking it and flushing it down the toilet, you're going to get it out into the environment, and it's going to help clean up the environment.
I like the idea of, that our...
Well, it needs a lot of study. I mean, I don't think, we could take pounds of EMERAMIDE and flush it down the toilet and clean out your rivers.
It will be a bit expensive to do that, but everyone is welcome to try and help.
It's expensive to put mercury down your toilet. I mean, we know that causes a lot of problems with a lot of people. So there's a lot of discussion here, and what we really need some young scientific MD, PhD types to get their hands on this product and study it, because I can't do that kind of study. I mean, I'm not qualified, but I think if we can get NBMI approved at any site, then people can start doing, medical centers can start using this to study. It'll be available. We got it. We have done phase 2 studies on Parkinson's patients, on people with thalassemia, which is iron overload, and on people with COPD, oxidative, what's called COPD. I know what it is. Chronic obstructive pulmonary disorder is what it's called. It's where they can't breathe and they die. And it did not cause a single significant adverse effect in any of those people. And it did not cure any of them either, but it did show signs, positive trends in the thalassemia and the Parkinson's patients. And so, but that needs to be proven yet.
Much more research needs to be done. But you and your team and yourself have done a great work with all the studies that you've done, everything that you've proven. So far we know we have an amazing compound with the capabilities of helping a lot of people in our community. As we said, mercury has done a lot of damage to our children. So anything that can help in any way whatsoever, I think should be something that should be studied. And as we said before, we need all the support from everyone just to move into, to push for research. My objective when I do these interviews is just to tell people that many things are going on, many studies are happening, many amazing people like yourself is working to help us, not just us, everyone that might have a health issue. But I think it's important that we all, push our governments just for more research. Research is everything. So one thing that I want to tell everyone is that it's been, we have the time that we have, but Dr. Hailey has very kindly accept answering all the questions that every one of you have sent me. So I will send it to him. He will reply to the questions and then we will publish them. So today it's been more like a talk between between him and I, where he's, tell us all his experience about with autism over the years. But I know there are a lot of particular questions that people have sent that it would be probably best answered in written so that everybody can read them and get to understand in depth. So, Dr. Haile, it's been a pleasure. It's really nice talking to you and hearing your story and hearing all the effort that you've made, that you've put into all this research. I really hope that FDA will come to sense and will grant you the approval, and that we will all be able to enjoy your supplement, by your company, with all the safety that you've done. And so,
just point out, it's not just the FDA, it's the EMA and INVIMA in South America. And, I think what we have firmly established, and the FDA agrees, a compound is without toxicity. I mean, any reasonable dose you would give a child or anything. And it's the developmental and reproductive toxicity studies, which are the most sensitive, showed no effect on any unborn child or in animal studies, not a single adverse effect that was significant. So the compound is safe. I mean, and this is but the problem is, since it's not approved as a drug, medical centers can't easily do studies on it.
Yeah,
that's where we need to get, because there's obviously going to be improvements in the delivery and the amount that is going to make it better. And that's going to be determined by somebody besides me.
Well, we really hope that gets to the point where we all are able to enjoy it. One thing that I want to pass on is that many of the parents have expressed their, how would I say that their hopes that you would write a book telling all the ins and outs of OSR. So I know, for what you told me before, that something is cooking. So I'm really hoping one day to be able to read a book from you, and together with many other parents will be waiting for that day. So once again, thank you very much for your time, and thank you very much for all the work that you've done till now, and hopefully soon we'll be seeing the results of all these efforts. Thank you, Doctor.
You're welcome. Have a good day.
You too.